Today we're going to be looking at section 8.4, which is on multiplying and dividing rational expressions. And that's what our goal is for today as well, is we're going to multiply and divide rational expressions. First thing we're going to talk about is something in simplified form. In polynomials in simplified form, or rational expressions in simplified form, when a rational expression has a numerator and a denominator that have no common factors other than plus or minus 1. When we talk about simplifying rational expressions, essentially we want to think of it as a fraction. Okay? And just like we have the fraction 4/6, it's not in simplified form because we can take and divide each of them by a 2. We can take 2 out of each of those and reduces it to 2/3. So our simplified form is going to be just like that when we're talking about rational expressions, only other than just factoring out a common factor like 2 or 4 or whatever it may be, we are going to factor out factors that are variables. So if we look at the example, we'll go, let's say if we have 4 times x plus 3 over x minus 5 times x plus 3. Well, in this case, they both have the factor of x plus 3. So I can cancel out the x plus 3, and my solution, or my simplified form, would be 4 over x minus 5. So that's what it means to simplify a rational expression. So let's look at example 1. It says simplify a rational expression. So simplify the expression if possible. So if we take this polynomial function, or the actually rational expression, we have x squared minus 8x plus 16 over x squared plus 2x minus 24. So the first thing we're going to need to do is write these as factors. Okay, so you have to factor them first. So if we factor this, let's factor the numerator. And this is going to be x and x. What are the factors of 16? Well, it's 1 and 16, 2 and 8, 4 and 4. Which one's going to get us to the negative 8? So it's going to end up being negative 4 and negative 4. So that's how we would factor the numerator. And then we have to factor the denominator. It's going to be x and x, factors of 24. Again, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which ones are going to get us to that 2? So we're going to look at 4 and 6. The 6 is going to be positive. There, the 4 is going to be negative. And now what we're going to do is look at which of those terms can cancel out. And notice that we have an x minus 4 in both of them. So those will cancel out. And so our simplified form is going to be x minus 4 over x plus 6. The next thing we're going to talk about is efficiency. And if you look in your book on page 574, it says efficiency is where manufacturers often package their products in a way that uses the least amount of packaging material. One measure of the efficiency of a package is the ratio, again ratio means fraction, of its surface area to its volume. The smaller the ratio, the more efficient the package. So what we're going to do is we're going to look at example 2. And that's on page 574 as well. It says a company makes kitchen canisters with the same base. Style 1 is a cylinder whose weight is equal to its radius. Style 2 is a cylinder whose height is twice its radius. So we want to find the surface area and volume of each canister. So the first thing we need to know is what are the formulas for the volume and the surface area of these canisters. So when we're talking about a cylinder, the volume is going to be the formula pi r squared h. And the surface area is going to be 2 pi r squared plus 2 pi r h. So those are the formulas that we're going to need. And then we're going to calculate the surface area and the volume of each canister. So if we look at canister 1, the volume is going to be pi times r squared times h. Well, it says in style 1 that the height is equal to the radius, so that's just another r. So in this case, it's going to be pi r cubed. And the surface area we're going to again put those in. So it's going to be 2 pi r squared plus 2 pi r h. And again, h is the same, so that's going to be a radius. So if we simplify that, now we're going to get the volume, or the surface area is going to equal 4 pi r squareds. So now there is the volume and the surface area for canister 1. Now if we do the same thing for canister 2, now instead of replacing the height with r, which is the same as the radius, in style 2 it says the height is twice as tall. So the volume for the second canister is going to be volume equals pi r squared times r, or 2r, because the height now is twice that. So this is going to be 2 pi r cubed. And now we're going to do the same thing with the surface area. And so if we look at the surface area, we're going to plug in, once again, 2 pi r squared plus 2 pi r h. Now instead of h, I'm writing twice my radius, which gives me 2 pi r squared plus 4 pi r squared, which is now 6 pi r squared as my surface area. So now we have the volume and the surface area for both canister 1 and canister 2. Step B says calculate the ratio of the surface area to the volume, so of each canister. So if we look at the surface area to the volume, that means our surface area is going to go on the top. So we have 4 pi r squared over pi r cubed. And we notice here that our pi's are going to cancel out. We have r squared in the numerator and r squared in the denominator. So this is going to be reduced to 4 over the radius. So that is the ratio of that one. If we go to canister 2, it says calculate the ratio of the surface area to the volume of each canister. So now let's do the second one. So the surface area again is going to go on the top. That's 6 pi r squared over the volume, which is 2 pi r cubed. And again, we're going to cancel out our like terms, taking out the common factors. So our pi's are gone. 6 divided by 2 is 3. And now we have r squared in the numerator and r cubed in the denominator. That gives us just a r in the denominator. Now, part 3, or question C, says, what do the ratios tell you about the efficiency of those two canisters? So remember, when we talked about efficiency, it said the smaller the ratio, the more efficient the packaging. So if we look at our two fractions, 4 over r and 3 over r, we know that 4 over r is greater than 3 over r. So that tells us that style 1 is less efficient than style 2. All right, so if you want to, go ahead and try these examples. You can pause the video and hit play when you're ready. And here, excuse me, here are the solutions to those 6 guided practice problems. The next thing we're going to talk about is multiplying rational expressions. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. Multiply the numerators, multiply the denominators, write the new fraction in simplified form. That's all you got to do. So if we look at the property here, A times C is AC, B times D is BD. So if we take an example, let's go with 5x squared over 2xy squared times 6xy cubed over 10y. So we're simply going to multiply the numerator. So 6 times 5 is 30. Then we have x cubed, y cubed. 2 times 10, if we go to now to the denominators, 2 times 10 is 20. We're going to have x, y cubed. And now we just start reducing stuff. The y cubes cancel out. We have 3 in the numerator. We have 3 x's and 2 in the denominator, so that's going to be x squared. And 30 divided by 20, well, that's going to be reduced to 3 halves. So we would end up with 3x squared over 2. And so that's exactly what example 3 is going to look like. We are going to run through this one the same way we did that example. So multiply. You can multiply first and then simplify, or you can simplify beforehand. Whichever method that you think you like better. So for in this example, I would look at this and say, oh, I have a 5 up here in the numerator and a 15 down here, so I'm going to cancel that out, and that's going to be 3. 5 divided by 15 is 3. And I'm going to do the same thing with my 3 and my 27. I'm going to take a 3 out of both of those, and so this is 9. And so now in the numerator, I'm going to have 9, and then I'm going to put my x's together, so it's going to be x to the 7th, y to the 3rd, over 3, x to the 5th, y to the 5th. And now if we reduce those, 9 over 3 reduces to just 3, and we're going to end up with x squared in the numerator and a y squared in the denominator. Because it would be 3 minus 5, so it would be y to the negative 2nd, which we'd move down to the denominator, make positive, and so here's your answer. C, 3x squared over y squared. All right, on to example 4. Now we're going to be multiplying rational expressions. Again, the first thing that we want to do when we do these problems is factor it completely. So what we're going to do is we're going to take this problem and we're going to factor everything completely and see what we can get to cancel out. So the first thing I'm going to do is I'm going to factor the first part. I'm going to take a negative 5 out of this first one, and I'm going to rewrite it so that it's going to be x squared, or actually a negative 5x. So it's going to be x minus 4. In the denominator, I'm going to take an x out. I'm going to get x minus 1. The second fraction, I'm going to factor this. It's going to be x plus 4 and x minus 1. And then I'm going to have x minus 4 and x plus 4 if I factor the second one. So now we're going to start seeing what can we all cancel out. Well, I have an x plus 4 here and here. Those can be gone. I have an x minus 4 in the numerator and an x minus 4 in the denominator. I can cancel those out. I have an x minus 1 in both of them. I can cancel those out. And now I have an x in the top and the bottom. I can cancel those out. And so we're left with an answer of negative 5. So the biggest thing is we want to factor these completely and see what like terms we have in the numerator and in the denominator and which ones will factor out. So we're going to do the same exact thing now with example 5. We're going to factor this. Now we have to remember this is the sum of cubes. So remember how to do that problem. So remember we always wrote this x cubed plus 2 cubed. So then in my denominator here I'd have x plus 2 and then it'd be x squared minus 2x plus 4. Well, that works out pretty nice because that's exactly what the numerator is on this side. And so we're going to see that these two will cancel out. And our answer will be x minus 4 over x plus 2. All right, so go ahead and do the next couple problems. You can pause the video and hit play when you are ready. And there's our answers for questions 8, 9, and 10. The last thing we're going to talk about today is dividing rational expressions. Now, to divide one rational expression by another, we're multiplying by the first rational expression by the reciprocal of the second rational expression. So we're simply multiplying by the reciprocal. So if we look at the property A over B divided by C over D, it's just A over B times D over C. So if we look at an example, we take 7 over x plus 1 divided by x plus 2 over 2x minus 3. So if we do this, we're simply going to multiply by the reciprocal. So it's going to be times 2x minus 3 and x plus 2. So essentially we're flipping that second fraction. So then our answer would be 7 times 2x minus 3 over x plus 1 times x plus 2. And notice in this problem, nothing cancels out. So that's how we're going to leave our answer. All right, looking at the last two examples. Again, the first thing you got to do is factor everything. So we're going to factor this. And the first one, the numerator is going to factor to x minus 7 and x plus 3. The denominator of the first fraction, we're going to take out a 5. We're going to get x plus 3 left. And now we're going to multiply. Instead of dividing, we're going to take this one, and that's in our denominator. We flip it upside down. It's going in our numerator, so it's going to be x minus 10 times x plus 10. Okay? So this one goes here. Then our numerator, if we flipped it, would go in the denominator. So we're going to go x and x, factors of 70 are going to be 7 and 10. So we're going to go plus 10 minus 7. And again, now it's exactly like the problems we did earlier. We have to look for the things that we can cancel out. We can cancel out an x plus 3. We can cancel out an x plus 10. We can cancel out an x minus 7. And our answer is going to be x minus 10 over 5. And so that's what we'll get for our answer in example 6. Now the same thing is going to be true for example 7. We're going to factor it. So this is going to take, we're going to factor the numerator. So we're going to get 3x and x, factors of 10, 1 and 10, 2 and 5. It looks like we're going to have 5 and 2, with this one being positive and negative. That'll give us 15 for the outsides and negative 2 for the inside, so that'll cancel out. We go 6x squared. Now remember, this second one is over 1. So if we multiply by the reciprocal, now we'll have 1 in the numerator, and then we can factor out an x, and we'll have 3x minus 2 in the denominator. And again, we can cancel out like terms. 3x minus 2's are gone, and our answer is going to end up being x plus 5 over 6x cubed. All right, at this time I want you to try the last two examples. So go ahead and pause the video. You can hit play when you are ready. And here are the answers for guided practice questions 11 and 12. So that is what section 8.4 is about. It is on multiplying and dividing rational expressions. Just remember, the first thing that you always have to do is you have to make sure that every polynomial that you have in your numerator and in your denominator are in factored form. So make sure all of your polynomials are in factored form, and then see what you can cancel out. The only difference between the multiplication and the division is once you get to the division, now we're multiplying by its reciprocal. So make sure that you factor all of these completely, and then reduce your fractions. Your assignment is on page 577, numbers 1 through 5, 7 through 43 odds.